Hey guys, Mr. Washam here. I'm going to give you some answers to the measurement lab. All right, here we go. All right, so there are several things in Miss Giesing's room to measure. I'm going to measure this biology book real quick. And so you can see on the biology book that it is 26 centimeters in length, 26 centimeters. And you'll notice that there's really, really tiny numbers in between. Those are millimeters. There's 10 millimeters per centimeter. So 26 times 10 would be 260 millimeters. Now, we, just to save time, have already given the answers to all of them, so you can pause the video right here and see the answers to all stations 1 through 3. And now you can pause the video right here and see the answers to station 4. All right, let's do some triple beam balance. Here is the giant paper clip. All right, you can see that it makes it unbalanced. When you use a triple beam balance, you want to start by moving the largest one first. All right, but that makes it too heavy, so I don't need that one. And then I'll move the smallest one next. And let's just start moving it. Oh, too heavy again. So I'll move it back. And there we go. So now I need to move the littlest guy. And I'm going to move that until it balances down here. Too heavy. And there we go. Almost there.
This looks like
there we go.
Smell like popcorn.
All right, so you can see I've got 10, and then 2 more, which makes 12, and then I go 1, 2, 3, 4 little dashes past the 2, so that's 10, and 2 make 12.4. 12.4 for the paper clip.
Stay exactly there.
So the paper clip is 12.4, but you notice that it needs to be in milligrams, not grams. So milli means thousand, so there's 1,000 milligrams in a gram. So I'm going to multiply this by 1,000 to get the correct answer. Right, now, one way to do that is to move the decimal. The other way is obviously to use a calculator. 12.4 times 1,000 equals 12,400. Okay? So 12,400. The other option of moving the decimal is the same. You move it 1, 2, 3 spots, which gets you 12,400. Same answer. Make sure these are in milligrams. The next one will all be in grams. Expo marker, balanced.
How much is this one?
15.2 grams, which is 15,200 milligrams. 15,200 milligrams.
10.
Paper clip, I'm getting just over 1. So approximately 1 gram, which would be 1,000 milligrams. Specifically here, it's 1.2. So 1.2 grams is 1,200 milligrams for the paper clip. Now I've got 10 paper clips, which you would think would be 10 times one paper clip, but it's actually not. This one comes out to 9.8, which would be 9,800 milligrams. All right, time for the stapler. It's 110, one more, 111.5. 111.5. Here is the tape dispenser, which is coming out at a nice even 450. 450. Now we have the pair of scissors, 27, just barely, 27. Here is the pencil, and it's coming in at just over 6.1 grams. So this would be the smallest amount of mass your triple beam balance could measure, the smallest amount. This would be the most amount of mass the triple beam balance could measure, the most amount of mass. All right, mass of an empty graduated cylinder, we're now on station 7, is 110 and 3.5, so 113.5. 113.5. I've now added 43 milliliters of water, and it's 155. 155 with 43 milliliters. Now added 97 milliliters of water, 97 milliliters, and it's 210.5 for 97 milliliters. And so that 97 milliliters needs to be in milligrams, so remember there's 1,000 in there, so you're going to multiply by 1,000. Or move your decimal 3 spots. So you're going to have So 210,500 milligrams. 210,500 milligrams. To find the correct measurement of water in a graduated cylinder, you want to get down eye level with it and read the bottom of the curve, which is called the meniscus. And that gives you the correct measurement of water. It's the bottom of the curve, the meniscus. All right, here's the answers for Station 8. Station 8 involves the car and the larger graduated cylinder. So you need to find yourself a volume of water. Here I've got 100 milliliters, and then I'm going to take the car and add it to the water, and you can see that the water goes up, and the water goes up to 1, 10, 11, 12. It goes up to 112, looks like 112 milliliters, which means the volume of the car was 12 milliliters because the water went up 12 milliliters. Finding the volume of the eraser is different because it all has square sides. You can use the ruler and do length times width times height. Length times width times height. Last station, this is now station 9, so there was the data table on the board. Object 1. Object 1 is a meter stick. A meter stick measures distance, and it can measure the distance in meters, centimeters, and millimeters, which would be M, cm, mm, all lowercase. Object 2. Object 2 is a triple beam balance. That's what we've been using in most of the video. A triple beam balance measures items in grams. Measures in grams. The abbreviation is lowercase g, and it's finding mass. Mass, not weight, mass. Object 3. Object 3 are the thermometers. Thermometers measure temperature. You can be in both degrees Fahrenheit or degrees Celsius. It's a capital F for Fahrenheit, a capital C for Celsius. Object 4 is the graduated cylinder, also used a lot in the lab today. The graduated cylinder measures volume. It measures it in milliliters. Milliliters, that's a lowercase m and a capital L, milliliters. And that is the graduated cylinder. And then finally, object 5 is a spring scale. A spring scale actually measures weight because gravity pulls the object down from the hook. You see there? It actually pulls it down. The spring scale is measured in newtons. Newton's abbreviation is a capital N, capital N. That's your lab.